Now in 5, 4.
Hello, everyone, and welcome back. This is the Digital Future event 2022. So the theme and topic this year is One Planet. So we're looking forward to invite all the students and academia, make some certain discussion on the special topic, One Planet. Because of the global warming and the environmental change, at the same time, we have the war on the side of the planet. So it's really special to reorganize all the knowledge and have this discussion on this topic. And I would like to briefly introduce the event. So we're in the first week and second week from June the 13th to June the 24th. We organized the PhD and Consortium, invite the expertise from all authors coming here to make certain debate discussions in this PhD Consortium. So this weekend, we'll have the opening ceremony for the Digital Future workshops and a whole day conference named Computational Design and Robotic Fabrication. So the theme and topic this year for the conference is hybrid intelligence. So welcome, join us in this on this Saturday. And the workshop will start from June the 26th to July the 3rd. So we have a very interesting setup for this year, including more than 130 workshops and from 48 countries, and we have more than 250 instructors. So this is a special of this year. We actually start to set up like 12 different linguistic language channels, and followed by the coordinators. They organize the different channel by different language to organize all the workshops and make reviews and discussions inside different channels. So the language coordinator we have like English, Chinese, Spanish, Portuguese, Arabic, Japanese, Korean, so on and so forth. So welcome to join us from different hubs, from different language channels. And at the same time, we're coming back to the PhD Consortium. We, this year, this certain time, we're from Tongji, and Tongji organized 3 courses. They're focused on topic of architecture philosophy, architecture theory, and architecture design methodology. So in the past 2 weeks, we invite fantastic expertise who actually gave fantastic lectures from different perspectives. So at the same time, tomorrow we will launch, the day after tomorrow, we will launch a new journal from Digital Futures named Architecture Intelligence. So that is guided by the scientific design thinking and focus on the 3 future scenarios, including the smart habitat, virtual habitat, and space habitat, and utilizing the evidence-based architectural research methodology and architectural intelligence reconstruct architectural knowledge system and creates the international new paradigm for the sustainable development. So welcome all the PhD candidates to contribute their research, and also welcome all the researchers. You can sharing your new knowledge on this platform. So the website is on the Springer, and the number of the journal is 44223. So welcome, join us. And in the first week, we actually organized 7 every day 1 lecture. The 7 lectures from Daniel Bolligen, Meta Thompson, Shichao Li, Ayla Berman from UVA, and Anthony Picon from Harvard GSD. Last weekend, actually, we organized 4 sessions to invited a numbers of young scholars to make their speech focus on 4 topics: advanced fabrication, robotics, AI and human-machine interaction, hybrid forms and the virtual architecture, and innovative structure and materials. So we spent a wonderful weekend with the young scholars. And this week, actually, today is the Friday, and we invited 7 important academia researchers gave fantastic lectures, including Matthias de Campo, Kilmo, Mark Borey, Liam Young, Peter Schumer. And today, it's a great honor we have Imro Ko here. And I would like to briefly introduce him and the topic of his lecture. Imro Ko is the Cohen Foundation Career Chair Professor and holds a joint professorship between the School of Architecture and Sustainable Sustainable Design, and that of Design and Artificial Intelligence at the Singapore University of Technology and Design, where he now directs artificial architecture. He is an expert consultant at ZJU Washington Joint Research Center on AI design, and his research projects have been supported by Design Singapore Council, AI Singapore, Urban Redevelopment Authority, Ministry of National Development, Ministry of Defense, and National Supercomputing Center Singapore. Imro obtained his PhD from School of Computer Science and Institute of Architecture at Ecro Polytechnic Federal de Lausanne, EPFL, from Zurich, with his dissertation titled Architectural Sampling, a formal basis for machine learnable architecture, which was nominated for the Best Thesis Prize and Labs Loeta Prize. And other breakthrough of the year, art and science as well. Trained as AA and Zaha Hadid architects in London, Imro has exhibited at New PS AI and Art Gallery, Venice Architecture Biennale, Victoria and Albert Museum, and the Art House. Published in ICCV, Design Computing Cognition, CADRA, CAD Future, AD, and Transformation, and taught at AA, Royal College of Art, Harvard GSD, UCL Berkeley, and Strela in Moscow, and also Vienna India Angelvanda in Vienna, DIA, Bauhaus Dessau, and many others. He is a co-founder of the New Architecture Group, NAG, and co-curator of AIA Architects. Imro is the author of the book Artificial and Architecture Intelligence in Design, published in 2020. So today he gave a spectral lecture, the topic named Sampling Architects on Artificial and Architecture Forms. So the main introduction for his lecture would be two different architects are now in conversation. The neural network architecture of deep learning modes in artificial intelligence, and the visual spatial configuration of building forms in the discipline of architecture. Together, they signal a shift in our contemporary conception and production of architecture forms. More importantly, both architectures are characterized by the plasticity that provides a basis to evolve its generativity and generalizability along statistical noise. So lecture will present the theory of architecture sampling in architecture such as complex coupling in conceptual and technical terms. A theory of design research projects will be introduced at the
Emmanuel, Philip has some technical issues. So if you like, you can start now. So let's welcome Emmanuel to co-host the lecture.
Right, sure. And then we won't wait for Philip then. He will join us somehow in between, I suppose. Yeah.
Yeah.
Right. Let me share my screen now. Okay. Can I see my slide? The presentation slide? Yeah. Right. Thanks. Yeah, thanks, Philip and Digital Futures for the invitation and also the very kind and long introduction. As mentioned, I'm an assistant professor at SUTD, Singapore University of Technology and Design, in two programs, one in architecture, the other one in design AI. And I direct my lab for artificial architecture, teaching courses in SUTD, mainly on deep learning and machine learning for both architecture students and also computer science students. Also, he mentioned that I'm a co-founder of the Neuroarchitecture Group, which actually consists of Matthias de Campo, Central Manager, and also Daniel Bulajan. So now, the sampling, the title for today's lecture might look slightly confusing or ambiguous at least. So what I'm alluding to is that there are, in fact, two different architectures which are now in conversation. So on the left, this architecture of sampling within the domain of AI. On the right, the sampling of architecture within the domain of architecture. So more concretely speaking, then on the left is really about the neural network architecture of deep learning models in AI that relies on a sampling mechanism, which you'll see in a bit in the lecture. And then on the right, the visual spatial configuration of architecture forms within the discipline of architecture, where architecture serves as the training data samples from which new samples of architecture forms might then be generated, inferred computationally. In the later part of the lecture, I will discuss these two architectures, more specifically looking at three key ideas: architecture sampling, architecture plasticity, and also architecture noise. So before going to the lecture proper, I think it will be quite useful to, or at least here visually, to orientate you within the kind of broader context in which I work. So here's a kind of a snapshot showing different kind of contexts that I worked within. So for instance, there are more kind of experimental, artistic, design-based arena, such as the exhibition in Venice Architecture Biennale on the left. Also, I will show later on a book that was generated with Adversary network that then was published and won the Golden Pin Design Award. And then there are also other kind of contexts, such as more highly technical AI conferences, such as the ICCV, which is the International Conference on Computer Vision. Also papers in these contexts, and also the NeurIPS workshop, where my work has been previously included in the AI art gallery. And other ones which are more industry related and as Philip already mentioned, many government agencies, but also collaboration with commercial offices, such as the AI Singapore, So just let me quickly go on to the next one. Some publication, such as for those who are interested, you can also check these book chapters that have contributed in these books. Most of them quite recent, such as except for the one with the edited by Jules Erezin on discrete architecture. Although my chapter was really about machine learning, using discrete as a way to sample forms. And then my own book, which is now, as of I think a few months ago, the E version is available. So if you are interested, you can also get a copy. And then, of course, Knowledge book, where mainly features some of my projects. I did not write anything in there, since it's a single authored book. However, there are other ones that talk about this notion of architecture plasticity, sampling, and even aesthetics in the other two books on the right. A quick glimpse of some of the content of these publications, like this one from my own book, published in 2020. The discrete book from 2019. The AD issue of the machine hallucination. And also a chapter on form specifically in the book Artificial Intelligence and Architecture from Shiloh. Yes, so some people have asked me why this strange name. So on the one level, which is the name of my lab, Artificial Architecture. So on one level, it is a kind of convenient compression of two subjects of interest of mine, AI and architecture, into a single hyphenated compound word, where each has a similar equal weightage and importance. But really, on another level, it is the idea that deep learning, machine learning of architectural forms can actually be framed as a process of artificializing and re-artificializing architecture itself. In other words, sampling and resampling architecture. So you see that here the word architecture is deeply nested within several function calls, the function artificial in this case. So this strange recursive remix of synthetic forms with increasing artificiality. In fact, architecture is the space of the artificial, according to Mark Leagley, who wrote in his essay published in 1991 in Assemblage, titled The Prosthetic Theory, The Disciplining of Architecture, where he wrote, displays from artifice into the artificial, architecture became a technological extension of the body that is neither natural nor cultural. Modern architecture is the space of the artificial. So in a sense, architecture might then be understood as less of a naturally or culturally generated form in this particular interpretation, but more of an artificially generated one. A very famous quote that everyone probably knows of, Winston Churchill speech at the meeting in the House of Lords in 1943, where he said, "We shape our buildings, and afterwards our buildings shape us." On the right is the cross-sectional view of the House of Commons. The idea of reshaping our buildings. So if we were to replace the word "we" as AI, then it is quite a different equation. So in this case, AI shape our buildings, and afterwards our building shape us. So the word artificiality can then be defined as not just the quality of being made or produced by human beings, rather than, and therefore unnatural, but also the quality of being made or produced by artificial beings or entities. A highly controversial anthropologist who promotes the idea of the dissociation of anthropology from the human is Tobias Rees, who wrote about what if the equation of anthropology, study of things human, with ethnography, the study and description of animals, were a recent event, and what if one set out to undo this equation? So his argument then is that the figure of the man, this abstract time and place independent figure of the man, was in fact invented and only really stabilized in Europe between 1630s and 1830s, which then in turn marked this sort of historical condition for the possibility of a discipline called anthropology. And more lately, in 2020, at the exhibition called the Beyond the Uncanny Valley, Being Human in the Age of AI. He wrote an essay, and I quote him, intelligence is a property of neural networks, which comes in many shapes and colors. That is, from a machine learning perspective, intelligence is a series, and humans are one entry within this series, one among many. So if, in this case, well, actually, he went as far as to say that could one rethink anthropological research as the continuous practice of de-anthropologizing anthropology. So if we transfer that kind of understanding, which is really the thing that interests me in terms of reading his work after Ethnos, is that how this destabilizing proposition might be carried across to architecture. So if we would ask this question, could one rethink architectural research as the continuous practice of de-anthropologizing architecture, then it is the idea of removing that human figure in a traditional way of thinking about the human figure, of course, and therefore perhaps also a historical condition that mark this possibility to escape and rethink about our discipline. Yep. So this decoupling of architecture is then quite interesting, this notion of the artificial. Now let's move on to the lecture proper. So that one's really a quick intro. So more specifically, as I mentioned, I'll look at 3 key conceptual formulation. They are architecture sampling, architecture plasticity, architecture noise. So architecture sampling is in fact the title of my PhD thesis at DPFL. The long version is architecture sampling, a formal basis for machine learning architecture. If you like, I can watch some of the earlier YouTube lecture that I gave at the AA Emerging Intelligence lecture series. And architectural plasticity is something that I've formulated and drawn from the work of French philosopher Catherine Malabou. If you like, you can also read a bit about it at the in the AD issue of Machine Hallucination, or you could watch a video also in a more recent one in Melbourne School of Design. Architectural noise is one that I'm currently developing, and I will be elaborating a bit more on that because it's also more timely now to discuss that, now that we are seeing other models that share similar notion of noise, such as DOE, other diffusion models, in addition to the GAN models that most architects are familiar with. So what are these concepts and how do they relate to one another? So before looking at each of them one by one, to then construct that sort of relationship in this diagram, so here very quickly, the plasticity of the new architecture machine, in this case, the center machine in the middle, which is the neural network or architecture itself, is a result, in fact, a result of noise injection and the samplings of inputs and outputs during that process. We'll break down this diagram a lot more later on. But I think I want to make a brief detour into some of the past work that have shaped my more recent work. So in 2016, interestingly in Shanghai, which was a year after the neural algorithm artistic style published by Leon Getz and his colleagues. I was teaching at the AA Shanghai Business School, and that was the first time that I was kind of testing neural style transfer in a kind of urban and architectural context at those scale. And this image is a publication of the Shanghai 10 folio edited by Tom Verbus on the 10th anniversary of the AA Shanghai Business School. So let me move on. So this eventually led to a few other iterations. Back then was a bit quiet in terms of the discourse in AI architecture. But this interest kind of continued to pursue for the following 2 years, starting with something as simple as 2.5D nearest door transfer of cities and floor plans back in 2016, to 2.5D semantic nearest door transfer of satellite imagery and maps in 2017. And then, in fact, with some combination of wave function collapse. And also the 3D sequence sampling in 2018. So 2016, really raw, really, it was about this idea of combining urban plans from Putong and Puxi in Shanghai, working with a group of students. I think it was at the Hong Kong Learning Center, I think Hong Kong U Learning Center. And then also looking at more interior floor plans in 2016, combining different content and style, using the optimization process of the pre-trained VGG 16. And then with some semantic constraint, which similar to Pix2Pix, but it's really not again. It's again based on an optimization process of pre-trained models. In this case, based on learning the texture of the Barcelona city. And then 3D sequence learning that embed Markov understanding, Markov sequences, Markov chains into that process, then generating 3D forms and those get rendered. But earlier on, I was looking at some smaller data set, but such as using the idea of eigenphases, eigenvectors, to learn from a small data set, in this case, just 20 floor plans, and then finding ways to, of course, in this case, finding the most important vectors to then do the interpolation, almost kind of latent representation. But that was a small data set with kind of approach, and I would say machine learning, but not deep learning yet. Yeah. Also instances of it just exploring. So in this case, alternating between two forms. So to this 2017, something that I was exploring back in EPFN, and also kind of moving in that space, that latent space. And then move on to 3D, where looking at, given any a set of, let's say, 20 forms, can we also likewise do this interpolation? On the left, we see this sort of eigenphase of the forms, eigenphases of the form, and the parameters listed based on their order of importance. Here also, it invokes a space. Yeah. Of course, fast forward to the more recent work from 2021 is the 17 Venice Architecture Biennale under the CDX. And here I got, here's a short video before we move on to discuss the more specific concepts. Just going to play this video. It's about 2 minutes. So here we're looking at the, in this case, it's a 3D generated adversarial network, but in interpolating that latent space, mainly looking at the exterior, but then also then 3D printed, which I show later on. These were then exhibited at various venues. And also, but more important, looking at the interior, here cutting a section across. And what was important for architectural forms is really the, not just the exterior, but the interior configuration. So here we're looking at the distribution of the circulation zone. And at the same time, the massing is trying to be, keeping not too, not some slim enough so that light could come in, but also the circulation kind of embed fire escape constraint, meaning apartments should not be too far away from the lifts and staircases. But these are kind of learned implicitly, which to me is very interesting. A kind of a shift in learning and without really needing rules. Here is just a teasing representation. The training set, the 3D models at the bottom of each of the model is the geolocation, the let long. that been so these models are scraped from the whole country, which is Singapore, which is a small country, so it's quite doable. Again, showing the training process, I try to converge. So here it's converging slowly, and at some point it's more interesting to have the less converged version. So here are some glimpses of the output. And of course, I'm always very interested in the histogram architecture by Superstudio. And much earlier on, I was here is to show a more simplified version, abstract version of that interpolation in very low resolution. But it served to show the massing, although not the interior. But the key idea here is looking at the strong and the weak, where sometimes they suffer from more collapse on the right. And also the grayscale represent the probability, the confidence of each voxel being considered as a building block of the building. And therefore we see on the one on the left is really confident because it's pretty well trained. The one on the right, however, is not quite the case. Here, looking at the idea of having a training set that could generate anything, inspired by Superstudio, right? Because they were generating chairs, buildings, tables, and city urban infrastructure from the same catalog. To me, that is almost the precursor of the notion of a training set, although they call it the catalog. Although in their case, it wasn't computational. That was a kind of 3D print array of interpolation between a chair structure and a slab block. So of course, in this particular research, it's not just kind of blindly throwing data points or build data models into the machine, but also initially there was some understanding of the morphological transformation within in the country, and at least in public housing, how it has evolved, and things that one should take note as we try to balance the diversity of the training set. So here just some image of the cut section of these again generated forms, and also a close-up animation of the interior cut. That video was a bit small, so I thought I could at least zoom in for you to see. Here we see again is doing the exterior and interior at the same time, of course. But we see that there's some consistency in terms of the connectivity between apartments and the vertical cores. So if we kind of take still frames of that, which are essentially three-dimensional, here we see I've actually encoded the vertical circulation as in darker tones. So top is the bottom row represent the cut section, and from left to right is the interpolation. So we see that it has learned some notion of cluster blocks, notion of slab blocks and point blocks. And then at times it became a bit slightly amorphous, where you have multiple staircases clustered together, connecting to corridors at various levels. Again, a zoom in of some of the, as it moves towards the point block configuration. And then this, again, a zoom in. So in cases where it starts to get crazy, you have crazy number of water tanks and crazy number of staircases, but still the connectivity works. We can actually identify the darker tones, which are the corridors. The lighter tone are the apartments' walls. So this same project was also recently exhibited at the Arts House, which is the oldest, the old Parliament building, where I think is where we got the independence. Well, they split from Malaysia, but that's a different discussion. So this exhibition, I Rise Urban Scales Between Human and Machine. The exhibition is interesting because it is a juxtaposition of two different modes of operation. So on the one hand it was my work, AI generated high-rise building in grayscale. And then the work of Singapore's cultural and medallion artist. He's a watercolorist, a very nice and friendly old man, Ong Kim Seng. So for information, in Singapore, if an artist got a cultural medallion, it's as if he has received the knighthood from the Queen in the UK. So on the left, this is the picture of the exhibition. On the left are my works. On the right, here's watercolors. A bit more, yeah. So both sides, the exhibition space was split into two. And then here, for instance, you saw the training just now. And in fact, on this side of the exhibition, you've got three different renderings. And they are actually different in terms of, like in this case, the one on the left is less evolved, meaning it has not fully converged, and therefore it has this interesting uncanny look to it, which is, this was really trained for 110 epochs, the one in the middle, which becomes a bit more architecturally plausible. At least the water tanks are up there. Here, the top part is still quite a mess. That one was trained for just 5 more epochs, and this one 10 more epochs, so 120 epochs. And they are very raw in the sense, but already you could see this suboptimal yet not quite fully converged forms are interesting. Like the one on the right side, this one, if you can see my cursor, it has 3 vertical stack. These are in fact the apartments because they're in lighter gray. They are connected by extremely generous circulation and terraces behind them. This is plausible theoretically and even desirable spatially, but financially impossible for developers because the so-called sellable floor area would not be sufficient. So the AI is interesting because it starts to kind of avoid certain notions, certain factors, but yet from a formal way of speaking and thinking is creating novel configuration. Here is a 3D printing SLA white resin at a scale of 1:100. This is just a fragment of it. It's not the whole high-rise building. Some zoom in of the, so we could see some of the balconies, some of the floors and walls, and even tables and chairs sometimes, yeah, for the communal spaces. Here we see that, so these are more evolved. These ones are about 2050 epochs, about 10 times, trained 10 times more, 20 times more, in fact, 20 times. Here are the 3D printed interpolated models at the scale 1:300, printed SLS nylon PA12 in white. Here again, you have the exterior and you cut a section, and here I'm just showing actually a freeze frame of the video. So let's move. So now they have some imagery in your of the project in mind. Let me continue with the conceptual illustration, starting with the architectural noise. So clearly, it's not about the new book Noise by the psychologist Daniel Kahneman, and who is the author of Thinking Fast and Slow. But interestingly enough, for design at least, or creative application, the opposite position of Kahneman is in fact allow us to attain generativity and generalizability within deep learning. So noise plays a key role in neural networks architecture, whether is it GAN, such as StyleGAN, whether it's diffusion models such as OpenAI, DALL-E, or Google's more recent ImageN. Noise is always there. So in fact, I would argue that most, if not all, deep generative models use noise distribution to learn and then approximate their training data distribution. So to take a more recent example of a deep generative model, on the right, I drew this high-level diagram of a diffusion model. So essentially, for those who are not that familiar with diffusion models, there are 2 processes. So first, starting at, so you have the training set at the bottom, let's say in this case, the digit 5, x0 at the step 0. So you add noise to it until the point it becomes pure noise. And this is a kind of in this case a Gaussian noise injection, a predefined forward, in this case an upward diffusion process, right? So you add noise sequentially, and then sequentially to a sample of the training set, and then you arrive at pure noise at xt, which is the predefined number of steps taken in the original paper. I think it was 1,000 steps. Then the second process is the reverse. So starting at xt, we do the denoising. Again, based on the same number of steps that was learned. So in this case, the network is learning the reverse process. In this case, the downward process of called the denoising diffusion process, if you like. And it sequentially removes noise from that pure noise to arrive at a new sample that looks like the training set. So noise is so important in these models that I think much needs to be discussed about its role in, as we think about not just neural network architecture, but also its implication and conceptual effects on the way we think about generative design. Or to take another example, the general adversary network. Again, here I also drew a diagram, but originally drew it for the SUTT book publication, the one that I mentioned just now, to generate 700 different book covers. So we'll show later on in the video about that process. But here we can see a similar process where the GAN model, in this case, a style GAN model, there are multiple injections of noise across different layers of the deep neural networks, specifically the generator. So if you zoom in, you see that there are noise that are being injected in the successive layers, but also, of course, you have the latent space, the Z, and also the intermediate latent space within them. So again, even in the case of the UNet-based pix-to-pix, for instance, it has dropouts as well, and dropout become a source of noise, although real noise is not really injected, but dropout became that mechanism for randomizing, right, adding noise to it. So we can see, so for those who are unfamiliar, you have the discriminator, you have the generator, and then you have the training set on the right, on top right. As we upsample it, the discriminator downsample it to figure out if it's a true image or a false image, and then calculate the loss end for the training. So this concept of noise might even actually be more interestingly explained with what I call the overfitted architecture hypothesis. Overfitting architecture hypothesis break down a bit. So we know what's underfitting, fitting, or overfitting, right? Generally, these are terms used in data science. So underfitting is basically low generalization. Fitting is good generalization. So, or more accurately speaking, the underfitting in this case, the diagonal line is unable to fit among the dots evenly, and therefore it has high loss and low accuracy, right? Bad with training data and definitely bad with new data. Fitting in this case is that the curve is able to convincingly fit among the dots evenly. It has low loss and high accuracy. In other words, good with training data and should be good with new data. Overfitting, which is the name of the hypothesis, is that the squiggly curve is too able to fit through each and every dot perfectly, and therefore it has low loss and low accuracy. In other words, good with training set, really bad with new data. So the idea of the overfitted brain hypothesis actually. So the idea of the overfitted architecture hypothesis came from something that I have been looking at, which is the overfitted brain hypothesis by neuroscientist and neurophilosopher Eric Hoyle, who proposed this back in quite early, actually, 2020. So he wrote something like this, as I quote him: dreams evolved to combat the brain's overfitting during its daily learning, that these dreams are a biological mechanism for increasing generalizability via the creation of corrupted sensory inputs from stochastic activities across the hierarchy of neural structures. In simpler terms, it means noise, essentially, right? So this ubiquitous problem in deep neural networks, DNNs, is often solved by models via noise injection. We saw it in diffusion models, we saw it in GAN models, for instance. In fact, if you think about it, in early days of creative coding, like in processing whatsoever, noise is such, the randomness is so important for the generative artwork or architecture, in fact. So noise via noise is actually in the form of noisy or corrupted inputs. So in that sense, similar to how the brain combats overfitting with dreams of corrupted noisy inputs, likewise, in order to generalize better, therefore more generative, in this case, we could frame the notion of generalizability as the capacity for generativity. So then the overfitted architecture hypothesis then is the idea that architecture machine now faces a similar challenge of overfitting, right? Like this cookie cutter production of architecture forms and embedding noise into its sampling. So now I'm not talking about adding noise to physical, I'm talking about adding noise within the generative models that we're using, specifically the neural networks. So embedding noise into its sampling, learning, and training processes is key to its generalizability and generativity for architecture design. So perhaps more vividly illustrated is this example, the book that I mentioned just now, produced for SUTD, which won the Golden Pin Design Award for the use of AI in book design. You'll see that there are some relation to the Venice Architecture Biennale work also in terms of the notion of generating variations. To run the, so just a, I think I should just run the video. So these are some pages from the book where I explain the process. Of course, that diagram that I showed you just now. If you're interested, you can get that book also. About 4 to 6 pages of explanation of the whole process of resampling and sampling. All, as I showed you in the picture, this recursive call of the artificializing process. This is a video. You should be able to hear the audio. The title of the book is called Forming Unforming. So the idea is we compile previous architecture work by students for the past 4 years or so. In fact, since 2017, I think. And then we use that as the basis to generate the book cover. So the idea is that the cover is not just a cover, the cover is the essence of the content across years. So you've got all those renderings, images from students, and then we then split them up so that we increase the number of data points. And then through that process of training with 8,530 assets, here we see the training set, the training process, and then iteratively choosing and curating within that process, right? With a increasingly reduced number of data points, meaning images. So here, for the final glance, you see, of course, because it's low res, right? We're training in much lower resolution. So again, add the AI upscaling, super resolution algorithm onto it. Again, a pre-trained model, and then generate these covers. So you can see at times certain configuration that looks like an urban plan, looks like a sectional cut, and this is the kind of power of these systems. To sort of even summarize visually, right, what was being done in the past years and whether there is such a thing as a SUTD architectural style by students. So a very different approach, unlike in the old days you would do, manipulating on pixels on Photoshop or Illustrator to design a cover, or to write a procedural code that is only limited in its range of generative cover design. So now that we have discussed quite briefly on the architecture noise, I would like to move on to architectural plasticity, leaving the most important concept, which is architecture sampling, to the later half of the lecture. So this diagram, architecture plasticity, it is the plasticity of the neural network architecture, but also the architecture forms that resulted from it. So architecture plasticity is actually drawn from a number of references that I've been thinking about. And I even mentioned it in some of my publications. So most notably, the idea from neuroscience, which is neuroplasticity, or in simple terms, the continuous and dynamic rewiring of the human brain. Therefore, the brain growth could be then understood as a non-linear reorganization rather than a linear optimization. It's a much more non-linear, messy process. That is adding, subtracting of neurons, connecting, disconnecting of synapses, mapping or remapping of the brain function across the anatomy of the brain, right? So here, neuroplasticity is the neuroplasticity of the brain. So a picture of well, this is maybe too much. Of course, the idea that the adult brain is not only capable of changing, but it does so continuously throughout life. And therefore, if we think about not just architecture, but the tools towards generativity, in our case, deep neural networks, as something that is continuous, that can be continuously changed, which is true. Every time you train a deep neural network model, it's a different thing. Even if it's the exact same architecture, exact same hyperparameters, it's a different thing. And you can continue to train. Well, whether it converges or not is a different story, but it does, in that sense, we kind of compress the evolution process and quicken the changing process in a continuous manner. And the concept of plasticity from an aesthetic dimension could be drawn from, as I mentioned, from the French philosopher Catherine Malabou, where she extended neuroplasticity beyond the biological, right, into the aesthetical, in the aesthetics, into ethical, in the ethical, the political. So from an aesthetic perspective, is this notion, or she talked about malleability, and in terms of ethical, is actually about treatment, repair, rescue. Political is about the responsibility of receiving and giving of form. So she actually, I mean, from the French understanding of the term plastic, right? So here is plastic, or plasticage, or plastique. So it actually has different meaning, especially the last one. It's an explosive substance. So in my text in the AD machine hallucination, I think I mentioned about the vanishing gradient, the mode collapse, as sharing some characteristic of this explosiveness. And therefore, I mentioned about the idea of the plastique. So it's drawn from the book here, What Shall We Do With Our Brains from 2004. Yeah, so the plasticity could be placed into extreme. From her philosopher text, we understand that it can be about taking form or annihilation of all forms, which is the explosion part. Which is probably understandable, maybe, because she was an ex-student of Jacques Derrida. And then if we trace back to architecture history, 1920s, when people talk about plastic arts, mainly to refer paintings and sculpture to just differentiate themselves from music and literature, which are a different form. But the term plastic then is not the material clearly, but the plasticity, the condition of stuff that can be formed into other stuff. The term Neoplasticism, coined by the artist Pierre Mondrian, was in fact a rejection of the plasticity of the past. And that's why I call it the new art. In fact, neo in that sense is new, right? But there is this so there's this notion of destroying the world of art as an object or thing. So you could even link that to this idea of objecthood. And then, of course, Theo van Dasberg, which I wrote about also in the other book, a chapter contribution, is the idea that it should be elemental, right? Of course, in this case, it is seen as elemental in its end result, but I'm talking about elemental in its composition within that generative machine. So therefore, it has this relation to discrete sampling, or in this case, autoregressive models. So so now I want to talk about architecture sampling, which happens all over, right? From the input to the output, and also in the process. We saw it just now. Here, sampling can be understood as sampling from a Gaussian distribution that then injects noise sequentially in the vision models, for instance, or in the GAN model. Sampling in this sense of sampling of data, architecture samples, your training set. And then architecture sampling as the output can also be understood as the sampling from a latent space, like the latent walk I showed you just now for the 3D GAN project. So sampling is not just about CADing anymore, right? It's something more abstract in a sense, like a synthesizer, like a sampler or sequencer in the music context. So the aesthetics of sampling. So I kind of broke it down in my thesis when I wrote the architecture sampling, a formal basis for machine learning architecture. I was really looking at 3 key aspects of it. First, the semantics of sampling, which can be understood from a pedagogical, technological, and aesthetical perspective. So here to elaborate a bit more, pedagogical, the word sampler is in fact a physical pattern reference in embroidery. And in the 16th century, and in 1880, for instance, it is also as a kind of a curriculum to train young ladies in embroidery work during the Victorian era, and then eventually as a printed instructional cross-stitch pattern book, which they call it the sampler, where you print symbols representing the different thread colors, essentially pixels, if you think about it, right? Cross-stitch patterns. And this is the beginning of that discretization in a way. And in the middle, so you can think about this from a pedagogical understanding of patterns and training, from a technological perspective in terms of converters and synthesizer. So here I'm showing the Chamberlin, the first magnetic tape sound reproducing musical instrument that was patented. Or more importantly, in fact, ADC, which is the analog to digital converter. So IBM here featuring the sample and hold circuit. So you have this whole process of quantization, discretization, and then binarization, if you can call it that way, to 0 and 1. And is that process sampling in discrete forms. And aesthetical one would then look at the non-parametric and the parametric. In fact, the non-parametric, before the deep learning days, in texture synthesis, the non-parametric method was really quite successful. Such as, so here in this case, the texture synthesis from non-parametric sampling. And then parametric sampling from the latent space in the first variational autocan encoders, VAE, like Klingma and Welling. And then, of course, the earliest parametric sampling approach from the latent space in first generation adversary network by Ian Goodfellow in 2014. Almost about 8 years ago. These are published. So on the one hand, exemplar learning from examples. And then we have the machine learning encoding, which is the technological understanding of sampling, and the probabilistic generation of new samples from existing samples. So the second one is the structures for sampling. So we talk about the semantics for sampling. Now we'll talk about structures for sampling. And this is highly formal way of understanding. So here we can look at from various moments within architecture history. For instance, in order to sample, you have to have some sort of format. So in this case, for instance, you can look at the work from Gordon Martha Clark, the Bingo, where he, in 1970s, where he literally cut up a building facade into squares. That's why the name Bingo. This is direct sampling. The indirect sampling, like the work of Rachel White-Reed in her Ghost project, where she cast the interior in a grid setup, right? Pieces, these plaster cast in that format. Or the infinite gridding work of Hiromi Fuji, in this case, the Miyata house, where the building actually looks like as if it's been cut up, although really only on the surfaces, right? Of course, more computationally is the work of Liner March in the encoding and decoding of floor plans as a Boolean matrix. Of course, he then converted into some kind of hexadecimal representation of forms, very compressed representation. And then if we look at beyond the grid understanding of the structure of something, we look at the sequence of something. Some of the earliest could be traced back to Luigi Moretti in the Palazzo Ducale of Urbino, which is the 3D sequence sampling with clay cast, right? Casting the entire interior space, and then 2D sampling, sequence sampling, the notion of sequence, right? It's been also discussed by Vedat Shumi in 1981 in Sequential House. Literally, that's the name of the project, Sequential House. And then 1D could be understood in the typewriter work of the No-Stop City, which is really the No-Stop City, the homogeneous living diagrams by Pizum, because it's one dimension simply because you type from left to right, top to bottom. And then the hierarchical notion, which is the closer to neural networks now. So beginning with Christopher Alexander in his notes of synthesis of form, the deterministic hierarchical sampling. So you deterministically split these into sets, right? That from that hierarchy, or the probabilistic hierarchical sampling in the Markovian design machine by Mike Beatty of UCL in the 1940s, or the more recent parametric hierarchical sampling, which is not really sampling because it's not learning something, but the structure, yes, the directed acyclic graph is a good representation of that mode of working. And then lastly, which is actually most fundamental, is the perception through sampling, which I kind of embed this notion of the artificiality in it, because it is a call to debunk, in fact, debunk throughout the most important mode of thinking about forms in architectural thinking, which in turn have somehow privileged certain modes of certain specific privileged modes of representation and perception. So here, the argument is that artificial sampling is in fact consists of no figure, no ground. We know that, for instance, from a model, yes, an AI model, you could actually split, do segmentation, but these are very artificial also. It's kind of a second layer. Really, it's just looking at that flat image. So no figure, no ground. In my essay that I wrote for the AD discrete sampling, I mentioned the work of Hiroshi Kawano. Interesting because he was doing this artificial Mondrian work, where literally these are discretized so-called pixels. Of course, after that he painted them, and it's a very different approach from, let's say, the one by Frederick Nake, which is more continuous. You can read a bit more in that text, but anyway, I'll move on. And then moving on to a tensor representation of images. So really, there's this idea of figure ground is artificial for the machine. It's something is more just out for us, I suppose. No parts, no whole, right? This is the idea of, so the first image is whole to parts relation as unique parts assembly, such as the neoclassical chair, armchair. Whole to parts relations such as the semantic lattice by William Mitchell in his Logic of Architecture book. Whole to parts relation as digital ontology, which we can find now in BIM software. And then, so it's arguing for no parts, no whole, no figure, no ground. No shapes, no grammar. Clearly, seemingly, but kind of, an attack on shape grammars. So here an image of the research by Huber and Wiesel in 1959, which actually inspired the invention of the CNN, because it was about the activation of the lower level layers with very basic shapes. So in this image is really the cat visual cortex neuron activation. And then, of course, young Lacan in his Lynette 5 in 1998 was really performative in recognizing the handwritten digits on checks. And and then the face detection, the Viola-Jones feature engineered kernels. And then later on, this particular text, which I find quite interesting because it claims that, which is actually quite true, texture as the primordial feature over shapes. So you're given an image, a texture of an elephant and the figure of a cat. If you give a person this image, the machine this image, you would think that it's an elephant, not a cat, because it's learning, it's prioritizing the texture more than the so-called figure ground. So in a way, to kind of summarize this whole idea of debunking the figure ground, the parts and whole, the shapes and grammars, is this idea that yes, no figure, no ground is a flattened world. Machinic sync of a satellite, for instance, is really a flattened. It's image from James Bridle, who talks about the mean aesthetics, but inherently it is flat. Resolutional. So we don't look at our parts at what scale. We talk about the resolution of the entire thing. So if you've done 3D machine sync of a 3D camera, in this case, if you use some scanner, you know that it scans the whole thing. It doesn't figure out which is the chair, which is the wall, and so on and so on. So resolution is actually the new reality, well, to us, but it's old reality for the machine. No shape, no grammar. So this idea of machinic sync of a deep neural network, where making decisions is probably better with statistics than rules. So examples of the activation, of course, the first auction AI generated painting by the Obvious collective, French collective, the portrait of Bellamy. So here, the visual thought experiment to just illustrate this idea of the no figure, no ground, right? The flattened field condition. So on the left, all of us should probably be quite familiar, is the field condition from 1997 by Stan Allen, which is really looking at the figure and the ground. Of course, he was influenced by minimalism, which is the distribution of objects. But the machinic vision is then, if you ignore the figure and ground, it's really almost like a convolution, right? Going across as recognizing patterns, features. And in this case, this is a kind of reanalyzing of this same figure, not as different rectangles, but actually figure and ground at the same time, right? The white and black. And then the parts and whole, we can, for instance, this thought experiment looking at the Rethel Berlin chair of 1923 from the Stewart period. So this is the idea of the different parts, although indeterminate parts, right? But if we look at the machinic vision, if it's really about resolution, then every resolution would create a different understanding. So here, what I'm showing is that at a very high resolution, you get this semantic map, and then as you move on, you get a low res, but the semantics will be completely different because the understanding of patterns is again different, right? There are more unique patterns, I would say. Yeah, there are less unique patterns. That's why you see there are more similar colors in certain areas. So it's really a resolution. And lastly, the probabilistic histogram architecture, well, I call it probabilistic because it was derived from the histogram architecture by SuperStudio in 1969 to 1972. Is so on the top, the architect's vision, the catalog. But really, these are just matrices, right? Where just numbers. And here I'm just showing if they could be already represented as numbers. Of course, there are some parts that are a bit more tricky with the curve, but the idea is that these could actually be learned as training set, which is the illusion that I referred to just now, that they're kind of a precursor, if understood from a machine learning perspective. So this is the book, the chapter in the script. That was the exhibition for SuperStudio. So I'm interested also because the idea that they were trying, these are the quote from SuperStudio, by the way, that is to have the least effort amidst the generalized reductive process. Of course, in reductive process, to them maybe is the idea of a neutralized style, but you can understand it, a reductive process, as a generic process, a generic generative model that is generalizable. And so it's supposed to be effortlessly generated. Like, for instance, these days with Imagen or DALL-E, it's almost effortless, right? Just type some text and done, right? For text to image models. And so for them it was effortlessly generated from their catalog, but for us would really be the AI model. And of course, this is the death of the architect, right? To them, which is an interesting separate discussion. This I showed just now. So again, the idea of form finding needs to be clarified. So it's between those of form optimization and form hallucination, right? So I'm not disagreeing with such a way of form finding, which is really the optimization from structural features, structural understanding. But they are useful, interesting as constraint-based optimization in structure and materials. However, that is not the only way. Which I mentioned in the 3GAN project from Venice Biennale. That project, the structural part could be post-processed, but it's not that interested in the optimization of the structure, but it's more about the space, right? Spatial variation. So you saw this just now. But here is the form of a building can then here be hallucinated with the form of chair. This is linked to even a whole discourse about analogical thinking or learning by analogy. The example of some of the chair to building projects in Europe, you've probably seen this before. But so here to just zoom in a bit, humble chair. It's clearly not the most structured chair. Strangely incomplete armrest with strangely incomplete armrest, backrest, leg support, and even the seat itself. It's uncanny familiarity. It's interesting. It's like a chair, but at the same time many chairs, right? But not yet quite the case. So this is sort of a subversion of the computational process in the dominant form finding paradigm. And if you still recall the overfitted brain hypothesis or dreaming, I like to remind ourselves that the two of the greatest and most influential figures, one, the godfather of deep learning, Geoffrey Hinton on the left, and the father of psychoanalysis, Sigmund Freud, had in fact considered sampling and dreaming as conceptually generative in process and in this latent in content. So here, for instance, the 1995 paper from Hinton, the wake-sleep algorithm for unsupervised neural networks. And I quote him, in the sleep phase, neurons are driven by generative connections. And then Freud, in his 1899 book, The Interpretation of essay, The Interpretation of Dreams, a century apart between two of these figures, the interpretation of dreams is the royal road to the knowledge of the unconscious activities of the mind. So there are some interesting relations, and especially these days when we talk about neuroaesthetics or AI aesthetics, such as deep dream, deep fake, machine hallucination, the uncanny, and so on and so forth. So in that sense, this overfitting and fitting is that spectrum is that of the convergence and divergence of familiarity and defamiliarity, determinancy, indeterminacy, plane, and well, the plateau, right, or the valley reach. So in fact, I also mentioned, other artists mentioned also the uncanny valley first proposed by the robotics professor Masahiro Mori in 1970. It is that strangeness that has great generative potential. Of course, we talk about the uncanny reach, right, which is the deliberate hijacking of, or the deliberate use of underperforming models, or the deliberate, in my case, for that 3DGAN project, is a premature use of a model during training. So Hertzman, Aaron Hertzman, wrote about it in his essay about this aesthetics of the interdeterminant, of interdeterminacy. right? To create indeterminate imagery, models must be good enough to produce realistic novel imagery, but not so good that all their outputs look like ordinary photographs. So this can be applied to architecture also. So if we were to rephrase Hertzmann's statement and adapt for architecture, then it would sound like this. To create indeterminate architecture, models must be good enough to produce realistic novel architecture, but not so good that all their outputs look like ordinary buildings. So these are some of the samples that I showed you just now, just kind of a closer look. And these are snapshots of the training process before they begin to converge into something more building-like, more determined. So far, we've been looking at mainly at the sampling of continuous space. Now I want to talk about sampling in discrete space, which is discrete sequence in this case. Quite recently, I released a few months ago the NFTs. So the models are generated by a 3D autoregressive model, which is transformer based. This one, the motivation really was originally for Children's Aid Society, which I was trying to bring in the furniture as this sort of uninviting and inviting object, right? That could symbolize the situation that these abused children were undergoing, going through. But in the end, crypto was not accepted as a valid currency for the organization, so it was not quite no go ahead in the end. But anyway, you can find the models, the NFTs, 3D NFTs on proof of stake in Tezo website, TEIA .art, I think. So these are the collection. And then this is just a web browser. I call it a video, so it's easier to see. You can click on any of them. Let's say this one. Okay, so they are essentially 3D. So they are sold as 3D objects. And also, well, with your iPhone AR ready. Yep, so let's move on. I kind of wrote some text about the point of that uncanny look, the seemingly dysfunctional conceptual illusion. So the script can actually be found even much earlier, as I mentioned just now, the theory of endosplit elementarism and or the neoplasticism of Pierre Mondrian, such as the Bauhaus. This project I showed a few years ago on the AI discrete, but it's a learning process of the machine learning process where we see moments of overfitting and we see moments of surprises, right? So these are the generated outputs based on the sequential learning. And of course, the ArchiZoom, the no-stop city as inspiration for a paper that was submitted 3 years ago, I think, to Cadrea, I think. Yeah, Cadrea. So is to discretize the game levels, right? To understand the spatial configuration. So yes, not the most practical project, but intellectually quite exciting. In the sense that we are looking, so here the Pokemon game levels, right? How to learn the Pokemon game levels at discrete pieces to sample it essentially and create a no-stop, not just a no-stop city, a no-stop Pokemon city, right? And going a bit further to understand certain biases, right? Here on the right, a bias towards the horizontal. I'll show you later on the Miss Van der Rohe project, the discrete Miss project that illustrate this idea of injecting biasness within that system. So here, for instance, this is the sample of the training set, and this is discretizing them into their, in this case kanji, because it's just more cool looking rather than numbers and letters. Also, it has more characters clearly. And then we could then start to generate, and begin to analyze. So we have houses, we have the ground, and we begin to analyze here the figure and ground, which is really a fake thing, and the semantics, right? The entrance of the house to the houses, the lakes, rivers, the gates, and with that, it is actually possible. So to push it to something that's more architectural, we can look at this project, which is the discrete means project. So one training data, a single piece, can we generate with a small data set approach? So in this case, it is actually possible, but it requires a process of discretization and a process of sampling probabilistically. So here, the floor plan that we're all very familiar with, this Vanderon Basnell Pavilion. In the one in this case, originally it was a kind of a 1 by 1 meter grid. So here is a 2 by 2 meters, quite different. And then here is a 0.5 by 0.5 resolution. So as I mentioned, it's resolutional, right? No figure, no ground is resolutional and it's probabilistic. And here, the sampling process, we can compare it at the just to show the scale. The red are the scale, the ones on the left, just the sets, the different states, excluding overlapping convolutions. So a stride of however that matches up to the size. So we have about the same number of states, discrete states, about 60 of them, more or less. So the generated instant could be based on a uniform probability distribution, which means that if you generate based on that, it means you're not learning anything and you get this mess. Or you could use the discrete states and do a kind of a true frequency count of each of the states, and you then generate something. But again, it's sampling without spatial relations, which is essentially not convolutional. And then one could start to play around with the biasness being added artificially in the system. Here is the kind of biasness towards the horizontal orientation by sampling more on the horizontal side in the horizontal orientation. And here in the case of a vertical artificially biased version, or here in a more fair and square way, both vertical and horizontal, but also the diagonal. So the legibility began to emerge. We begin to see some legible forms, like, but also some surprising forms. You have a really long, short bench. You have some columns distributed around. You have the sculpture. You have strange stairs that go down and then up again to nowhere. But the relation of that long wall with the bench can still be identified, or the proximity of the cross-shaped columns with the T-shaped columns with the walls as well. So we do see some of these, and of course we could start to adjust the so-called the temperature, right? The fidelity of the generator and the original by relaxing the biasness. Same thing could be used in this case. By the way, the roof has been removed so that it's easier to look at interior configuration. This other project, which is the La Marala Roja project, is again looking at this system has been will be presented next week, week of the next in Glasgow. The project has been done a long time, but just I didn't have time to actually write it. And so you can check that. It's the design, computing, and connection. I'm also running a deep learning workshop there on next Saturday. So here, taking two examples, right? Subsampling, taking first the staircase A and B, which is the one is open zigzag staircase configuration, and the other one an enclosed spiral staircase configuration, right? A and B. So then if we have just two data points, in this case, two models, can we start to do arithmetic without a large data set? So this research was really about substitutional logic related to Markov random field. So here is the idea. of doing it at different resolution. As I mentioned, the resolution is extremely important because it changes the number of discrete states and the nature of the discrete states. So here, if we do just sample from a single model, can get this, sample from this single model, get this at different resolution. As we go lower in resolution, we see some legibility, but also it becomes less interesting. Here is that with plus A plus B, we get this. Yeah. In more detailed explanation, which is based on different algorithm, is this in this case is also published. I think 2 years ago, is based on the idea of learning-based wave function collapse that I wrote about in the first version, and then this one with the examples more vividly explained. So in this case, there are no rules. You give it 2 models, you figure out the correlations, the transition matrix, and then you figure out how to build this on. So again, sampling. If we sample at the resolution of 3 by 3, we get about 450 states. Here, the numbers represent the frequency, right? And we can do that by extracting. So here I'm showing the thing in my thesis. I also wrote about the grid propagation sampling, is to extract these in a convolutional sense. But if we just increase the resolution, or rather reduce the resolution, sorry, 5 by 5 by 5, we has this explosion of number of states. So one of the key problem with that algorithm is difficulty in scalability. It begins to explode, and the number of states and the transition matrix to maintain become impossible. This is just showing at that resolution, learning the transitions. So some examples of the performing the arithmetics in probabilistic space. Here, there isn't a latent space, but there is a probabilistic space in terms of sequence. And so domino A, mesodomino A, mesodomino B, which is a fictitious version that I created, just so that it's almost the antithesis, and therefore providing a means to evaluate the output, whether is it truly the 5 points of architecture or the 5 other points of architecture, shear walls, and so on and so forth. And we could also start to do a subtraction of specific states, right? So adjusting the probabilistic space. So therefore, in this case, we don't actually, I mean, this is at a much lower, this is like a much lower resolution. At a more granular resolution, and therefore is a lot more messy looking. There is this whole catalog in my thesis in PPFL. You can check the whole catalog. So at different resolution, we get every row represent a different resolution. So as we go higher, you start to create some stuff that seems more plausible, but probably less interesting. Last few projects. This is something that a thing that I published with the Transformation Journal of Media, Culture and Technology, the special issue called Artificial Creativity in Sweden. The project is really to build some kind of a recursive artificial urban sketcher, right? So here we see the traditional understanding of urban sketcher. So the interest is with these 2 diagrams, right? So photography is where you have the reality, you record it, you reproduce it with the camera, and you get this photo. And sketching is this kind of a compression, almost like an autoencoder, right? The encoder is the abstraction, the decoder is the creation, or you could call it, yeah. So in that sense, it is a very different process. And the sketching of the human by the human is this process. But for the AI, how about the AI? What does it mean? So I mentioned about this similarity in dimensional reduction, right? To create this strange latent space for subsequent sampling. So it has that characteristic. So here, just to clarify the fundamental difference in terms of intentionality and abstraction. So here is the standard Photoshop edge detection algorithms. You get nothing really, because it's not just add the edge detection filter, right? On the right is what a human would draw with sense making, right? So this is a quick of the kind of data set that's being used. It's actually thousands of videos. So here we see that the colors are black or white, very simple. The strokes are fixed. Yeah. So, and then using that to generate a new city we call it in a cartoony way, but actually these are the most important architecture features that one probably looked at when one were to drive through the streets in Singapore. So it's basically the output of an AI model. So of course, different streets have different characteristics, right? If you go drive through a street with modern buildings, you probably see more edges, and not the ornaments. But in the case of civic district, for instance, more preserved conservation like building, you see other stuff. So the idea is to split that data set into 3 different regions, of which about thousands of images. So here is a zoom in of the central area. So on the left, the buildings in black, the street view in photographic, and also in photographs, and these are in sketches. So just kind of zoom in quickly. These are the photographic scenes from Google Street View, and then you have the sketches of these corresponding views. And here is kind of a still frame of that animation that you saw just now. But more importantly is this process. I mentioned about the recursive artificializing process at work. And in this case, it is the idea that you have a image translation problem, but you recursively run it. Theoretically, it could be infinite, right? Therefore, the infinite. So you could do A to B conditioner again, for instance, A to B and then B to A, and then A to B and then B to A based on the output. So this to the point, to what point is the question. So here we see that you have a model that does A to B, and then you have the same output to a B to A, and then you can go on forever. And of course there's similarity, but there's begin to diversify, right? You see some clouds and all that. And that is quite interesting because it's the kind of hyper artificializing process with deep neural networks. And we can do it in the other direction, right? So B to A and then A to B and B to A, and do it infinitely. And in this case, sketch to the photos and then photos to the sketch, and so on and so forth. Yeah, I have some other, okay, I have 10 minutes, I think. Right, Philip? I still have some time, right?
If you have time.
Okay. Yep. So now I'm going to show some experiment with my undergraduate students at SUTD. It is also something that I've been thinking about how to kind of teach a student from pedagogical perspective, right? And which is a paper that presentation that I made a month ago in Galicia in the former methods in architecture symposium. And this is this idea of the associative synthesis. So what is associative synthesis, right? The idea of association, the idea of synthesis. So we could look at this term generally in 2 perspectives, right? Drawing from different domain understanding. So on the left, we could, let's say, look at the theory of bisociation by Koesteler in 1964, where 2 planes of two concepts represented by 2 planes come together, right, to create this bisociation. Or we can look at the work by René Magritte, ce n'est pas une bit, the treachery of images, which is the play of the word and form, word and image, right? But these are highly subjective association, which is what we're really good at as humans. And on the other hand, so I have this kind of a split, right, where what we are probably good at, we could make use in architecture education, and what is good with the deep neural networks or could be seen, could be more technically driven. So of course, when we usually talk about associative design, we think about parametric architecture, right? Associative modeling, but that is just one side of the coin, right? So on the one hand, we have the subjective versus the objective, qualitative versus quantitative, conceptual versus geometric, semantic versus synthetic, subconscious, which is the kind of psychoanalytical aspect of it, the uncanny thing coming in, and the conscious, the implicit, which is like such as the latent space and all that, versus in dreams and all that implicit occurrence, and the explicit, the even paradoxical versus the logical. So the paradoxical is extremely interesting because it is so unlikely that we associate different things together, and sometimes this is where it creates this shift in conceptual space, right? The conceptual plane. So yes, the human on one side, the neural networks on the other side. So then the question was about how might deep learning models be appropriate for architectural co-creation, in this case from a pedagogical perspective, through an associative design synthesis process. So I'm showing just 3 projects that, and kind of split them into, because it was a paper presentation that it should be published, I don't know, soon. Yeah, but it's in process. You should be able to read it soon, maybe half a year's time, maybe. So the brief, the speculation, concept, data, model, synthesis. So first project, and so because they are undergraduate students, so it's how to somehow frame the problem that is such that it's small enough but loose enough, and yet granting them the space to learn. Not just the technical part of it, but also its conceptual implication in architectural thinking. So one project looks at very simple sculptures and this association of sculptures and landscape, such as the data set of Henry Moore sculptures. Association of fictions and facts with the Studio Ghibli's films. Association of past and future built forms, such as the serpentine pavilions. Right, so they all have varying associative affordance for co-creation. So just to run quite quickly, because these are some of the texts that I use for the presentation, is to look at the formal characteristic of sculptures in generating landscape architecture. Seemingly not related, but interestingly enough, there are some formal novelty in there from the result of the experiment. And the other one is the fictional architecture of anime film with existing architecture of reality, is the unconditional generative models, right? And also combining it with our image captioning models to have as artificial layer of interpretation, which serve as a counterpoint for the designer, at least in this case, the student designer, to reflect on the differences between the human perception and the machine perception. And then we have the formal progression in recent architecture as the next in trend architecture, which is about predicting what's the new trend, right? And there is this whole process of generation, classification, and also explanation. So let's move on to the first one, which is this project. I would skip these. So it's really about the association of the intricacy of the surface articulation at the scale of the sculpture, but then applied to landscape. So this is a latent one of these kind of sculptures that been used, learning that latent space. But this is not it, because what you will want then is actually, so there were about thousands of images, but there's other combination which I don't go through in detail. You can read the text, the published paper eventually. The deep encoder decoder network, which is called the BaseNet, which help in the processing at least. So here an example. See, we see that the output is similar, but in terms of the surface articulation or even material, they're very different. Like this mother and child motif, right, from Henry Moore's repertoire of sculptures. We see that the hand, the arm is missing, and certain things are missing. The legs are quite similar, but then we could then transfer this process, in this case, the Biggs model, to transfer that articulation in the context. So we know that for Henry Moore sculptures, there are voids and non-voids, right? What if we upscale it? Just like if we use a latent space that's been trained with chairs and stat blocks, what do we get? This by association, right? So likewise, what can we get out of it? So these are some examples from students trying to experiment how to interpret them. Some of the 3D prints, which actually looks way more interesting. Some videos, so a quick video of the process involved. So you run the basenet to remove the background, for instance, and then of course this is just running on the notebook to look at the training and then applying it. So what if we could then decide the landscape without deciding the contour? So we decide the shape in 2D, but we don't decide the contours. The contour is a result of the sculptural transference, the the articulate surface. So these are just some visualization, but not important. Studio Ghibli's film, again, fiction to fact, fact to fiction. This is an example of a kind of standard image, still frames from his film. So here is the association of a fiction architecture expression in anime and with the less forgiving reality of conventional buildings, right? So in this case, you have lots of still frames with 17 anime films, and then you try to learn from them. Yeah, a mix of style again, using the idea of design by an analogy. And here are some examples of the output. These are synthetic output from the model that look pretty Ghibli's-like, Studio Ghibli's-like. But here, this is with the pre-trained, a model has been pre-trained with buildings, right? This one with automobile, which is interesting because it starts to create some forms that are more object-like, which you'll see in a bit. So here, for instance, these one are generated based on the pre-trained model with cars, right? So it's begin to morph because it is initially biased, but we retain that biasness throughout the process by not training it too much, too long, and with too many new data sets to retain a balance. So here we see that some buildings actually look like a bit like a car, right? Even with a windscreen and so on and so forth. And then we then use an image captioning model to understand what these images represent to the machine. So the interesting perceptual differences as compared to what a human would see. So the image to text captioning process. Some latent work with the pre-trained with the buildings, and one pre-trained with the automobile model. The one on the right seems not moving, but it's just because it's slow in this as it moves in that latent space. And now it starts moving. So the one on the left looks a bit more disturbed because of its inherent biasness, whereas the one on the right looks typically quite building-like, even church-like. It is because of that underlying biasness. And the last project, which is the idea of the next Entrant architecture, right? So in this case, the Serpentine Pavilion for 2020, which doesn't exist, right? Because of the pandemic. So the idea is to understand if one could then use that very short but very well constrained history, meaning the project has the same site, right? It has the same scale, same budget, same format essentially, and that's quite perfect for training. So here from year 2000 to year 2020, what can we get out of this? So here we're learning different images of the different buildings, and we have to balance it also because in the beginning it was really all Fujimoto's building because his pavilion was among the very popular ones, and it's all around the internet, or at least those in the pre-internet years would be, of course, a bit more difficult to find online. So here we're looking at adding a few other stuff into this analysis. So here on the right are the outputs, but also using the investigate neural network to understand the neuron activation. So, but before that, I show you the latent work of these pavilion. Sometimes you see the one by John Laval, the red thing, and sometimes you see zoom tall like black building. But they are, to some extent, you do see the diversity. Later on, you probably see a bit of Fujimoto on the left. Yeah, this is the point where it becomes the Fujimoto building. Okay, just wait for a bit, at least half of it. At times it becomes a drawing somehow, like just now, right? It almost becomes like here, it becomes a drawing. Here we see, so it's moving that latency a bit, but how do we more accurately say that, this is a more Fujimoto building. This is a more zoom tall building, more Zaha building in this latent space. So therefore, the next step taken was to create a classification model to identify which was the ratio. Is it 50% more zoom tall and 30% more Zaha, and so on and so forth? And are we able to then control this by association in numerical terms? And that would be quite interesting. Let's move on. So there are a few things that can be observed here. Is that the well-formed design? So here, for instance, 3 scenarios observed from the general images, right? That will help you distinguish what's good and what's bad, or at least humanly. Well-formed design should be unreadable. Okay, normal design should not. Yeah, I think not. Simply replicate the source design and should be well interpolated and should not be locally repetitive. So sometimes you see locally. So let's say the first row, that is too familiar. It doesn't add value, right? There's no true by association involved or associative combination. The second row design, they are visually illegible in a way for further geometric rationalization. So it's not that helpful, but of course, it's really up to the individual to interpret these images. And the third row is where you see a highly cell repetitive situation where you kept seeing these pitched roofs all over. Nothing really normal. And then if we throw it into a classification model that's been trained with this our own data set, yeah, of course with transfer learning to quicken the process, we see that given any image on in the middle, the number represents the index. This one looks, funny enough, for the model, look like 100% Pangary. Here, for instance, the third one is about 50-50 between Ito and Zaha. And so we can see that this kind of mix, but at some point, if it's based on observation, too mixed up with like all 10 pavilions being in there at the same time, it becomes somehow less interesting because we lost the ability to recognize anything. And this is a kind of a Excel sheet representation of that same thing in terms of percentages and of the from the classifier, from the softmax activation. And here is another way to investigate. Of course, this picture is not the pavilion, but it's part of the Serpentine gallery wing. But here it's just to show, to understand what are the things that are being looked at. So again, this notion of a figure ground and all that is just completely abandoned here because they're not looking at those things. Everything is a pixel, right? Because it's an image. So the red part that we saw are the more salient area, and the blue part the pixels that indicate negative activation from this analysis. So of course we can do analysis for many, right? This is, so we can then, so the other question is, yes, we generated something, we kind of could curate which are the more interesting and novel looking images. What's next is to create a kind of organizer, or in this particular context, it's possible simply because these buildings have been built, right? They have been built, therefore we have tectonic references, we have drawings, construction details, and all that. And it's when, so this is the human part comes in, right? To synthesize the construct. Let's say you have an output that looks like this. So it's a bit zoomed out, and maybe so it's 17% of this. It's 50% from the 2019. So we can then begin to synthesize these architectural, very specific architectonic element into the creation process, which can be highly subjective, of course, but at least there is some kind of a guide that the translation should at least contain 17% of let's say from the 2018 pavilion, and 50% of the one from 2019, right? And then we do a translation, which is what architects are good at, right? And here, for instance, with the same image and the same so-called organizer, right? The multimodal organizer. Two students would have interpreted the same thing differently, like in this case, the two different interpretation and then 3D printed. So yeah, I think I'm almost done. This is the last project, which is not part of the paper, but something else, is to, again, associatively draw from the use of AI for facial recognition, facial aging, and in the context of facade aging. So this is the very early prototype to do some recognition and understanding of how to oldify or youngify a building. I think I showed it last time, maybe in some future context. Youngify usually is not that interesting because it becomes more like a modern building with no ornaments. But the old one looks quite interesting, almost rotten in a sense, right? The input and the output. And some translation based on the associative framework. The before and after, so in this case, the refurbishment, alteration and addition to an existing building. So this is quite difficult because it's not easy to get before and after data sets. So one have to figure out a way to solve this problem by doing it simultaneously, the before and after in the latent space. So here we see the before, plausible before after, and some before after snapshot of the pairs of facades, right? So sometimes if you analyze it a bit more deeply, you see addition of extension, recomposition, scaling, adding of an attic extension like here, or splitting it into different parts, or changing it completely in this case, but retaining the texture, the colors, and of course for the understanding of the interior distribution. So we are at the end. So I leave, this is the last diagram. So far we've talked about all, I mean, there was the last part of the lecture was really showing some examples, right, to illustrate the notion of some architectural sampling, architectural plasticity, and architectural noise. And for those who are interested, could look at some of the, I've listed some more recent and related text. I think that, this. So again, unfortunately, because of other commitments, this year I couldn't run a workshop at the Digital Future. So, but I think there are many workshops, so it's fine. So 2020 during the pandemic, I did the discrete sampling workshop, which really was about the continuous sampling. And then last year was on AI sampling, which was really about discrete sequence. Yep. I won't run this. You can check out the video yourself on the the Digital Future YouTube channel. Right. I think this is it for me. Thanks.
Thank you so much, Imro. I think it's most complete lecture I have ever participated and listened to your contribution. I think it's remarkable. I need to revalue your contribution to the society. I think it's great research. In terms of, we invite several speakers on this platform. I think your research is really have a really good framework, firstly, and the second time it's really deep, goes to the interesting details how to implement the artificial intelligence into architecture. So you try to set up another AA in Singapore, the name which artificial architecture. I think we can starting some question from your AA, which is so interesting as a starting point from 2020, and you actually doing very interesting works and really productive. Actually, we find the papers, read the papers, and also today we can see a lot of examples based on not only your research but also your teaching studios. I think which give us different scenarios we can looking into the artificial architecture you mentioned. So I think it's really interesting. It's a lot of information today, which is based on maybe a PhD thesis, which I want to carefully read. Is that open from EPFL? Your thesis?
Yeah, you can download from EPFL.
Yeah. I want to
if you're from ETH, you can also download it.
Great. That's fantastic. I think the main diagram you put forward as your last slide and the very beginning, which based on the three topics you mentioned today: architecture sample, architecture plasticity, and architecture noise. I think that's the fundamental knowledge you set up, on which I think it's really interesting to firstly talk about artificial, because artificial in your design is quite different to the traditional artificial understanding, which is based on the intelligence, not only from the human experience, but also I think it's greatly from the algorithm. So we'll address your future research, I think, totally on the re-understanding and on the anthropology and also anthropology you mentioned at the very beginning of your lecture. So what do you think, firstly, your framework of research, how would you like to frame your AA in Singapore in the future? Do you think you will contribute or devote most of the algorithms part or the working flow or the future initial toolbox you want to set up? So how would you like to address your framework of AA? Could you briefly introduce that?
Right, thanks. Yeah, before I talk about that, so
it's a lab. It's a lab.
Yeah,
it's a laboratory.
Yes, it's a lab. Yes, so because I joined SVTD quite about 3 years ago, so almost, and I started a lab called Artificial Architecture, and there are actually many other projects, but those are NBA kind of project, non-disclosable with industry partners, and so I can't show those, but there are some novel neural network architecture being developed in the lab for the built industry, built environment industry. So before talking about that, I showed some slides from about the anthropological framework that newer contemporary anthropologists like Professor Rees been kind of abandoning. In fact, it was highly criticized for his position. But it's interesting. I presented this idea at the Royal Anthropology Institute in the UK just a week or 2 weeks ago. And the reception was quite good. It was with the AI and creativity panel, and there was an anthropologist there as well, but you have artists and so on and so forth. But the de-anthropologizing process is relevant to architecture because we always see the human is the, well, if you call it plainly, the user, right? But that is not necessarily the case, or at least not necessarily you have this as the core of our discipline, right? I mean, everyone knows about what, let's say, Lian talked about, data center, the post-human and all that. Is obvious, right? So therefore, this relationship, this kind of exchange with other related domains will be highly beneficial. So within my lab, I'm involved in other non-architecture contexts. Like in September, I should be going to Pennsylvania to present at the International Congress for the Empirical Aesthetics. So it was about, it will be about neuroaesthetics, which is the idea that there are some neurological basis for our aesthetic experience. So going beyond the kind of Kantian, Immanuel Kant, or that kind of, we talk about the sublime, the beautiful, and so on and so forth. But that new position, which is actually closer to neuroarchitecture, right? Neuro, not neural, neuroarchitecture, to kind of understand from their perspective because they claim that the part of the visual context get activated, right? If you look at the reference from Zimir Zeki, he said that, for instance, if you look at a Piet Mondrian painting, the artists are in fact activating the lower neural layer, just like a convolutional neural networks, right? The beginning is the low kind of edges, and then you have the form. But it is that process of us creating that combination that create this aesthetic experience. So again, on the neuroscience part, there are much interest. On the anthropology side, there are also great interest. Of course, the artwork is always interesting. Therefore, the recent venturing into the NFT space, or even the intelligent eye NFTs, right? That something that I'm organizing. So in Singapore, we have a few events, forthcoming events. One is the International Built Environment Week, which I'm involved. I'm curating a section on AI and architecture. So I've got people from using AI with synthetic data. Synthetic data is something that is getting increasingly useful, important, even necessary, maybe from a design perspective especially. And also people from the NFT world that embed NFTs within the metaverse with some intelligence in there. Right, let's say you have a GPT-3 in an NFT within a metaverse. What does it mean then? It's extremely interesting. So bringing these different people coming together, and also the other thing that I'm working on is I probably should only announce it later on. Is some design festival that will be involved. Is looking at urban heat island effect from a poetic perspective, meaning not from just simply analyzing the heat distribution within the city, but also at the kind of a human first person perspective, right? So technologies such as thermal imaging will be brought in, but then ingested by AI models to create something that's more personal, experiential. So I think something that is quite missing currently, well, at least well, actually even generally, but in Singapore, for instance, is this this lack of seeing the necessary overlap with the say the digital humanities and other stuff. So therefore, many of the industry project is actually very technical, like ranging from automated progress report, right? So you do object recognition and then you update on 360 camera, but those are interesting from a very technical perspective, which in my case within the lab is to migrate this understanding to rethink about its application in the creative industry, right? And likewise, there are also I have a project with the Urban Redevelopment Authority, which is really about creating graph neural networks to understand the nodes within the city that contribute to, let's say, non-compliance, or so not just the overall network, but also the building within the building. Is that strange interface that often architects kind of ignore or be less sensitive towards. And in this case, the graph neural network is very useful because we could somehow have understand or identify causal relations, right? Causal, which are the nodes that contribute to some problem in the urban side. But today I'm really presenting the more experimental, more interesting for students also, right? More provocative part of it, more artsy part of the research. So, so within Singapore, the infrastructure is actually very good. So, like I have computing cluster in the National Supercomputing. I could just use their cluster, so that's very convenient. And I do the training over there, and also other AI Singapore, where they encourage collaboration with industry partners with the IHL, Institute of Higher Learning. So I've been approached by industry partners to work on under that kind of framework, which is, I think, quite attractive for industry partners who want to be involved in the AI area. Yeah.
Yeah, great. Yeah. I think recent years, Singapore make great progress, not only in academic, but also I think attract talent people, and also the infrastructure system in the university, and collaboration between some industry partners to the university research. I think you make a really great progress. We can see that, yeah. And also we're looking forward to see your lab. I think with a great name, Artificial Architecture. How would you like to address this lab into the discipline, actually the architecture department, including the creative in Singapore? So we can see the potentialness in your lecture. So we're looking forward to invite you more often. And as to I think the most interesting part for me is your sampling analyze. I think you're subdividing to the semantic structure and the perception of sampling. That is a thinking methodology, and also you make a lot of implementation in your teaching studio, and also analyze like different examples like Ms. Vandero Barcelona Pavilion. I think it's a great example to teaching the student how to understand your perception on AI. I think which based on maybe the flattenness understanding firstly, and then coming by the resolutionary study, and followed by the probabilistic methodology. You analyze and reassemble such kind of voxels or pixels from different scale to recreate the new possibility. So it's quite good and deep, like it's from the semantic of sampling and noise based on this kind of relationship. And that's actually a thinking methodology in artificial intelligence. So my question goes to, I think it's really good lecture because it's easily for students to understand artificial intelligence, although it's quite based on very complicated algorithms and mathematics, and also the thinking method is totally challenge the tradition human-based, human-centric thinking methodology, which is totally a new manifesto or new paradigm shift in the design process and for the future generation. So I'm curious, this kind of sampling and noise design methodology need to base on a certain kind of toolbox and certain kind of working flow. So could you analyze a little bit about your teaching? I think the student work are fantastic, and also the case study analysis are fantastic. You create certain kind of toolbox like the sketches toolbox, and including the voxel and in different scenarios like different films or different like animations that create the real different futures, which based on the new, as you mentioned, the perceptions you define it as a no figure, no ground, no parts, no shape, no grammar. So, but actually it's, we make a very interesting discussion last night with Peter Truman. He also have a similar idea. He separately defined what is matter and what is object. The object in his definition is something with no figure, no ground, no use, but it's totally abstract, but including everything, including every possibility, which is located in the latent space. Maybe human being need to searching your requirements based on your definition. So that's a quite philosophy analyze for the artificial intelligence, the perception, collaboration between human and the machine. So I think the question goes to this. I think most highlight important is the perception, how the perception of concepts which can create something new. As a last example, Fujimoto's style, or maybe to predict something new. So how would you like to address such strong design skills from artificial intelligence can embed it or can really create something new? Is there any new paradigm like parametricism coming, which goes to a certain kind of style? And then Patrick Schumer would like to review on that. But I think when we're looking back, parametricism is a thinking method and design method, and some like Rhino, this kind of platforms which produce and support this paradigm going on in the past 10 years, 15 years. So what you're doing is something like which is a new formalism to me, because this kind of a latent space or the searching or this kind of probabilistic formation will also, do you think it will also lead us to some formalism or form paradigm which have some certain style in the creative industry or in the design styles, because which based on the genetic actually, which is from something already exists of some master's work or maybe the urban environment, or maybe certain information you define through the big data. So how do you like to address certain kind of perception and creativity in the discussion of artificial intelligence? Could you analyze a little bit on that?
Yes, so if we, I mean, I mentioned about the non-parametric and the parametric, but from a kind of a textual synthesis understanding in the computer science world, which is, so if you think about it, the neural network is a parametric model, right? Because we are tweaking the weights of the connections. Of course, these are homogeneous computational units, right? We, unlike, let's say, Grasshopper, you define this particular battery as to explode the mesh and so on and so forth. But neural networks are generic, right? It's just, I don't know, layers of convolution, batch normalization, and activation, and so on and so forth. They are generic units. Yes, they are specific activation functions, and so on and so forth. But in the end, it's the same thing, kind of. So that's kind of, I think it's probably more beneficial to think about parametricism or parametric process as as a process, yes, as a process, as a mechanism, just like noise sampling and plasticity serve that mechanism. So we're not talking about a specific formalism to it. But again, I also mentioned about the aesthetics of sampling, right? So the aesthetics actually work behind the scene. Something may be generated based on the sampling process, but they can look completely different. It could look very Pomo, it can look very deconstructivist, and so on and so forth. But the underlying mechanism are the same for both, right? So I find it more useful, at least for everyone, to see it from that perspective, that the aesthetic is driven based on that mechanism, rather than a visible style, such as, I mean, the argument, let's say, Mario Capo mentioned about this chunkiness, the big data and all that. But you can't avoid the fact that there are forms that deviate from that definition. It is not quite possible. I mean, it's useful, which I suppose that's why the whole point of style and categorization makes sense for humans, because it's a way to simplify or abstract understanding, right? To differentiate. But as groups of sets and subsets, right? So I think therefore I talk so much about these mechanisms that have no specific style. But of course, unfortunately or fortunately, in the end, many of my work look quite discrete voxel-like because of my own preference. Even the choice of not having any colors is almost my own inclination. And talking about you also asked this question about within the school. Currently, there's this slight problem of the supply and demand problem. So industry wants architects who are able to do certain things. First, they need to understand, right, what we're doing, which itself is quite difficult. So there must be some kind of exchange between university and industry. So they see the picture, they see the potential, yes, then they're ready to invest. But even if they're ready, we don't have enough graduates to supplement. So now there are some kind of exchange at the student level with industry partners, so that there is kind of my transfer of knowledge across, of course, supervised by myself if it's an AI project, that to ensure this supply demand thing would not collapse. It is at the point of collapsing. That's why the government created AI Singapore to train apprentices. So in fact, for those projects under the AI Singapore, there will be apprentices joining my lab for a few months to learn stuff and then move back again to industry. So in terms of the teaching, so the question is, what do we teach, right, in architecture school? I mean, clearly it should not be a course that is, like the standard machine learning course. It should be something else, but then what is it? Yes, so therefore I created the course when I joined SUTD, the creative machine learning elective. And that some of the works that you saw, they were from that course. Third year student, very young, just started, playing with Grasshopper and Chem Engine, just throwing them, activation, function, optimization, stochastic gradient descent, that sort of thing. So how much to teach and how much not to teach, so that they don't get trapped. So I'm very much against this kind of black box approach, where, so in my course, I actually draw up the neural network architecture so that they have an understanding, a high level understanding. Let's say this idea of gender discriminator, this idea of concatenation of feature maps. What is the feature maps? What is striding? At least they should understand the most important architectures like CNN, LSTM, so on and so forth. And then once they have that, they have an understanding. Yes, they most likely they won't fully understand, but at least they know that they have tried to understand. And then you set up a kind of a framework where it's just like in the old days at Cooper Union, you have this kind of a nice square problem, right? You have the cube, right? John Hadouk create that kind of a constrained world that they can work on. So likewise, how do we create that protected space, but yet not too controlled, where students could test out, they could actually get their hands dirty to train and look at the code. Those who are, some students are, much smarter, right? So those who are way more into coding, they can change the code and we can discuss, and then at the end we end up designing some new architecture, right? You never know. Some students are very smart, and but then after the first year, I started to identify some problem. So on the one hand, we're teaching the technical part, but it is completely divorced from any architectural history. So they cannot bring what they have learned in history theory class into this. It's like something so foreign, so technical. So so I started to kind of bring in, Cedric Price, Nicholas Negroponte, and more recent other ones as well, and also other discourse from the art world, so that they see that this is not kind of an isolated, specialized domain, because it's not eventually, for them as the future architect, they have no choice. It's inevitable. They have to face it. So on the one hand, the technical aspect for design exploration that is kind of reasonably contained for them to understand enough and do a lot. And on the other hand, supporting it. And in fact, the architect, I have this course, which is compulsory. It's called, which is actually called Artificial Architecture Intelligence in Design. And I actually wrote the book in 2020 as a primer to kickstart. So I wasn't planning to actually write a book, but I was asked to write a book. So that was the beginning of that book, and is to provide that theoretical foundation, so that students would be more critical. Otherwise, they are facing a black box technical machine, and then they are also having this black box theoretical foundation, which is highly problematic. You don't want, to have some graduates that are just, in the old days, they call it the parametric monkeys, right? That, they're just kind of good at connecting wires and done. They have no sense of building scale, and you don't want that. You want critical thinkers who not just able to apply AI in the built environment, but actually steer the discipline based on their understanding of what happened before, and therefore what might happen in the future. Yeah. So yes, theory and technical has to come together.
Mm-hmm. Great. I appreciate your introduction on your understanding of AI. I think I really agree with you. I think we have some knowledge which very deeply in our discipline. That's when we make use of the new tools and new thinking methods. Still, we need to address everything into the deepness of the creation. Yeah, I think that's the most difficult part when we address our teaching. And I think your theory is really clear and really easily for our to understand. But actually, we can find profound, deeply philosophy thinking which embedded in your lecture. So I really appreciate on that. I think your understanding on artificial intelligence is really very produce a really good framework. So we are looking forward to have you more often and contribute more to the society, and including in China, including globally. I think Digital Futures is a platform we try to make promotions for the architecture education, and including the most importantly about digital in architecture. I think your research is really impressive today, because it's like a holistic conclusion or maybe introduction of all your research over the past few years. So that's fantastic. So thanks a lot for your contribution to the community. So looking forward to have more keep in touch with each other, and looking forward to give more support. Especially, we just launched the new journal, Artificial Intelligence, Architecture Intelligence. So we're looking forward to read good papers from your team. I think looking forward you give us more support. So
right.
Definitely
I'm supportive. Thanks.
I think it's around 2.5 hours. So thanks a lot for your lecture. So great thanks, and looking forward to meet you offline very soon.
Yeah, hopefully, yes.
Yeah.
Take care. Thanks for the invitation.
Thank you very much.